Class 9. Subject Science Physics. Chapter 7 Motion. Topic to be learned in this video, Equation of Motion. Equations of motion. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion, and the distance covered by it in a certain interval by a set of equations known as the equations of motion. For convenience, a set of 3 such equations are given below. Equation first. V is equal to u plus at. Equation second. S is equal to ut plus half at square. Equation third. 2as is equal to v square minus u square, where u is equal initial velocity, v is equal final velocity, a is equal acceleration, s is equal distance, t is equal time. The equation first describe the velocity-time relation. The equation second represent the position-time relation. And the third equation represents the relation between the position and velocity, can be obtained from equation first and second by eliminating t. Derivation of equations of motion. First equation of motion. Consider a body having initial velocity u. Suppose it moves a uniform acceleration a. After time t, its final velocity becomes v. Now we have acceleration is equal to change in velocity divided by time taken. A is equal to v minus u divided by t. T is equal to v minus u. V is equal to u plus at. Second equation of motion. Suppose a body has an initial velocity u and uniform acceleration a for time t, so that its final velocity becomes v. The distance traveled by moving body in time t is s, then the average velocity is equal to total distance traveled divided by total time taken. Average velocity is equal to s upon t. Average velocity can also be written as u plus v divided by 2. From equation 1 and 2, s divided by t is equal to u plus v divided by 2. The first equation of motion v is equal to u plus at. Substitution the value of v in equation 3, we get s divided by t is equal to u plus at divided by 2 is equal to 2u plus at divided by 2. Now s is equal to 2u plus at multiplied by t and divide by 2. We get s is equal to ut plus half at square. Third equation of motion. From the first equation of motion, v is equal to u plus at. v minus u is equal to at. We get t is equal to v minus u divided by a. We know s divided by t is equal to u plus v divided by 2. Now we get 2s is equal to u plus v multiplied by t. Then 2s is equal to u plus v multiplied by v minus u divided by a. We get 2as is equal to v plus u multiply v minus u. Then 2as is equal to v square minus u square. Example. A train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance traveled by the train for attaining this velocity. Solution. We have been given initial velocity u is equal to 0, final velocity v is equal to 72 km per hour. We change km per hour into meter per second is equal to 20 meter per second. and time t is equal to 5 minutes, the minutes changes into second is equal to 300 seconds. From first equation of motion we know that A is equal to V minus U divided by T equal to 20 meter per second minus 0 meter per second divided by 300 seconds. We get 1 upon 15 meter per second square. In second case, from third equation of motion we have 2as is equal to v square minus u square. 2as is equal to v square minus 0. Thus, s is equal to v square is divided by 2a equal to 20 meter per second square is divided by 2 multiply 1 upon 15 meter per second square. We get 3000 meters. Meter change in kilometer is 3 kilometer. The acceleration of the train is 1 upon 15 meter per second square and the distance travelled is 3 kilometer. Example. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. Solution. We are given that initial velocity u is equal to 18 km per hour. It is changed into 5 meter per second. Final velocity v is equal to 36 km per hour. It's also changed into 10 meter per second. And time t is equal to 5 seconds. From the first equation of motion, we have A is equal to v minus u is divided by t. A is equal to 10 minus 5 meter per second is divided by 5 seconds. We get 1 meter per second square. From the second equation of motion, we have S is equal to ut plus half at square. Putting the value 5 meter per second into 5 second plus half into 1 meter per second square into 5 second whole square. We get 25 meter plus 12.5 meter is equal to 37.5 meter. The acceleration of the car is 1 meter per second square and the distance covered is 37.5 meter. Example, the brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. Solution. We have been given A is equal to minus 6 meter per second square, t is equal to 2 seconds, and v is equal to 0 meter per second. From first equation of motion we know that v is equal to u plus at. Putting the given value, we get 0 equal to u plus minus 6 meter per second square into 2 seconds. Or u is equal 12 meter per second. From second equation of motion we get S is equal to ut plus half at square. Putting the value in the equation is equal to 12 meter per second into 2 second plus half of minus 6 meter per second square into 2 square second is equal to 24 meter minus 12 meter. We get 12 meter. Thus, the car will move 12 meter before it stops after the application of brakes. Can you now appreciate why drivers are cautioned to maintain some distance between vehicles while traveling on the road? Uniform circular motion. The movement of a body following a circular path is called a circular motion. Now, the motion of a body moving with constant speed along a circular path is called uniform circular motion. Here, the speed is constant but the velocity changes. When a body moves in a circle, it is called circular motion. When a body moves in a circular path with uniform speed it called uniform circular motion. The figure given below shows the motion of an athlete along closed tracks of different shapes. Thanks for watching. Please like and subscribe my channel.